Hi and welcome to this overview video where we'll look at the new features in P5 version 5.6, starting with LTFS data exchange, allowing labeling, reading and writing of LTFS media, along with restoring from indexed jobs back to LTFS. Enhanced cloud support means support for Microsoft Azure, plus Hitachi and Wasabi via the generic S3 option. Fast seeding of cloud-based archive allows the use of appliances such as the Backblaze Fireball and Amazon's Snowball to quickly migrate local data up to cloud storage. Reversing the client-server connection allows clients to keep in touch with servers and avoid issues with firewalls. A new deletion mode in P5 Synchronize helps avoid issues with target storage filling up. Parallel file transfers increase overall throughput via multiple copies running at the same time. And finally, P5 Synchronize includes the ability to restore from a sync target location back to a folder of your choice, and the ability to run a manual sync in an ad hoc fashion. Let's now take a look at all of this new stuff in the product itself. Let's begin by taking a look at the new LTFS Exchange feature, which is part of the Archive module. So under Archive, down at the bottom, you'll see LTFS Exchange. In order to show this to you, I'll be using a standalone LTO drive that I've already added to my configuration in the normal way. So going back to LTFS Exchange, my drive, my standalone tape drive, is occupied. By clicking Label, I can create an LTFS volume in the drive. LTFS volumes are distinct from regular P5 backup or archive volumes, so a volume needs to be labeled as LTFS. So let's give this one the name test01. I will reformat this tape because it has previously been formatted, and I will create the LTFS file system. Now we wait a little while whilst a couple of partitions are written to the tape. These permit the tape to have its own list of what it contains so that the tape can be inserted into another LTFS compatible system, drive and software, and the data can be read from the tape. All the drivers necessary to support LTFS are included within the P5 product, so there's no need to install anything within the operating system, and LTFS support is cross-platform. We don't mount the LTFS tape into the operating system either, so this avoids a lot of problems that are caused when that happens. The label job is completed, so I can now select my LTFS volume, which is now showing up with its name, and we can write some data via the write button. So the write button gives us a file picker. I can browse some local folders on this machine, and I might want to archive, and I want to write this sample pics folder which contains some image data to my tape. So I select my source folder, I then select my mounted LTFS volume test01 and start the copy. Immediately the files are being copied to the tape and we get a report of how much has been done so far. When this is finished, we'll be able to read some of those files back from the tape. Copy has completed pretty quickly, so that data now resides on that LTFS volume, which could be now put into a different system. But just to show you how you would recover data from a tape, once mounted, we will read the inventory on the tape to see what's there, and then clicking the read button will allow you to browse the tape. So I can see on my test01 tape, I have this sample pics folder with the JPEGs inside. And if I want to restore that, I can select that for restore, followed by a target folder. So maybe I make a new folder on my desktop called restore, select that one, select target folder, and then we start the copy, and we now recover that data back from the tape back onto the desktop folder that we just created, which has already happened. Finally, in the LTFS module, whilst you have an LTFS volume mounted, as we currently do, it's possible to visit an index and restore data from an existing index, which may be on disk or tape, back to the LTFS mounted volume. So if I look inside of my archive index here and browse down and locate something I want to restore, maybe this folder here, when I go to restore this and I select a restore location via this file picker button, you'll see the LTFS volume that's currently mounted shows up, and I can choose the LTFS tape as the location I would like my P5 archive data to be restored back to. So this allows you to make a selection of data that you've already archived using P5 Archive and restore it back to an LTFS tape. P5 version 5.6 expands the list of storage vendors, cloud storage vendors, to include Microsoft Azure, Hitachi S3 and Wasabi S3. If I click to create a new cloud service, the drop-down menu here now includes Microsoft Azure. Wasabi and Hitachi S3 are both supported via the generic S3 option. So if you have either of those cloud vendors set up, you'll be able to connect using all of those credentials listed there. I'm just going to quickly show you how to configure Microsoft Azure. I have an existing Azure connection here. So the fields required to configure Azure are the account name, access key and container. Now if I just click into my Azure management account here, to set this up you have to first of all set up a storage account. I've created one called P560 Archive and you need to use the type or kind blob storage. Within this account you will then get access keys. So here is a key which gets configured under my P560 Archive account name, and you can see P560 Archive is used as the account name in here, and the access key will be this one that I've got highlighted here. Finally, the container is the equivalent of the S3 bucket, and that is configured down here under blobs. I have created a blob called P560 Archive Container, and that is what I use as the container field in here. I already did a little bit of archiving to this container, so you can drill into it from here, and now I can see my P5 volumes represented as folders within this blob within the Microsoft Azure cloud storage. So to explain how using a cloud vendor's storage that they ship you works, let's assume that this diagram represents your site on the left and the cloud vendor's equipment on the right hand side, and you have some kind of server on which there's lots of data that you wish to archive into the cloud, but to archive it all over the wide area network connection would take too long. So what you can do is have the cloud vendor send you some kind of disk storage, normally a NAS device as I understand it. And then once you've received that, you do some configuration on your P5 server whereby you create a pool for cloud storage and you create a disk library on the cloud vendor's disk that they've sent you, and then you archive via that pool and archive all your data into a disk library on this storage. So on here you'll basically be creating a bunch of folders which will represent the volumes that exist within your pool. So once that's done, you then send the disk library back to the cloud vendor, and the cloud vendor then copies the contents of that disk library into a bucket. So here's our cloud vendor's bucket, also called a blob and various other things by different cloud vendors. So once that's happened and your volume folders, though these folders over here now reside inside of our bucket over here, we basically do some configuration where we detach the pool so that it's no longer expecting that the storage is local, and then we reattach the pool basically by pointing everything back at the cloud vendor's bucket. So how this is done I will now show you in the product's UI. So within the P5 UI under Archive Pools, here we have a pool, and you'll see if you right click on it that there is now the option to detach the pool. That's the point at which you send the storage which contains the library where the volumes are stored up to the cloud vendor, and then reattaching the pool once that has happened and you want to connect P5 back up to the cloud service. Now the scope of doing all of this is rather beyond the length of time I want to spend on it in this video. So there is a web page that explains this procedure in detail. If you point your browsers at news.jpy.com and visit the knowledge base section, find this P5 transfer to cloud storage using an import service article, and this takes you through the process in some detail. looking specifically at a Backblaze B2 firewall. So I recommend that you have a read of that if this is something that's of interest to you, to get all the details that you need to actually configure it yourself. P5 runs on host machines either as a server, as we have here, where jobs are configured and monitored and scheduled, or as a P5 client machine, which can act as a source or destination for data on one of the jobs that's being run on the server, and that applies for backup, archive, backup to go and synchronize jobs. Now traditionally, or at least up to version 5.6, the server always contacts the client via the TCP IP network in order to send or receive data to that client machine. Now that will be a problem if the client machine is sitting behind a firewall, which would mean that the server can't access that remote client via the IP network. So the new feature in P5 version 5.6 is that a remote P5 server can be added to the client, and this allows the client to connect back to the server rather than it being the other way around, again via TCP IP, and this connection is permanently open from that point onwards. So the P5 client maintains a connection back to the server, which means the server doesn't have to connect to the client traversing the firewall, which might not be possible. The client is then added onto the server in the normal way, but whenever a job runs that requires the server to access the client, it will use this permanent connection that's already been opened by the client, and data will pass through that, which removes the need for the server to contact the client directly. This new feature enables the kind of workflow where you can host a P5 server in the cloud in the center of this diagram and provide backup or replication to a number of satellite offices, as you can see around the edge here, where each one has a firewall protecting it. So we could now quite easily configure a workflow where each of these satellite offices is backing up to the central server without having to do any complex network configuration to provide access to those remote offices. Okay, so let's run through the setup of this remote client connection. To illustrate this to you, I've got two P5 servers installed across these two different tabs. So on the left hand side, this is my cloud-based server. This is a AWS Linux instance running P5. All I've done so far is input a license to activate the product, and what we'll do is we'll create a sync plan that will sync a remote client back to the local machine in the cloud. And the remote client is represented on the tab on the right. This is a P5 installation on a broadband connection on Wi-Fi without any inbound IP connection possible to it. So all of the IP will be outbound from this location, although the job will run from the cloud server. So we don't need a license on this remote site, but we do need to configure the remote connection back to the server. So to do that, we use the P5 menu over here, and we choose Agent Setup, and then Remote P5 Server on the left-hand side, and we click New. In here, we will provide the IP or DNS name of the cloud-based server and a login to start with. So that done, I'll apply the changes, and now I'm going to enable the client and enable the reverse connection. Apply that and register on the backup server. This now comes back and says that we're successfully registered on the backup server, and in future I could use the check button to make sure that that connection is still valid. So that's done. All I'm going to do now is note the local host ID. So this is the unique host ID for this installation, and I'll copy that because we'll need to use that on the server to identify this remote client. And now I can close this window. So now moving back to the server, under Synchronize, I'm going to add the remote machine as a client. So I do this in the normal way, clicking New, and I'll call this my remote client, and it's a server. Instead of providing the TCP IP address though here, I will paste in the host ID of the remote client that's already connecting back to the server. So the server just needs to identify that client from various clients that might be connecting back, and I'll provide authentication for that client and apply that change. So that's accepted. I can close that window. If I wanted to, I can configure compression and encryption here, but I won't do that now. And so now I have my remote client in my list, and I could ping this one to check that we have a connection to it, which we do. So I can now go ahead and make a sync plan. Over here, new sync plan. Let's call it remote sync. And the source of the data is going to be my remote client, which I can browse using the browse button. So now we're browsing the file systems on the remote client. I'm going to choose a folder to synchronize back. Okay, so here's my sync source folder, and the destination will be on the localhost machine at this folder here. And finally, I'll configure this with a schedule to synchronize and update every day at 7 AM. Apply and close. I'll apply all the changes, and now if I run this sync plan manually and view the job monitor window, I see my job running, and we're now receiving the data back from the remote client back to the server running in the cloud. So from this point forwards, the remote client remains in touch with the server, and the server decides at 7 AM each day to run the job where it will update its local copy of this remote folder on the remote P5 client, and the job's completed. So let's take a look at an example of a synchronization between a source and a destination, so we can see how the two delete modes work. So on the left hand side, this is my source data. I'm just indicating here that there are some new files in the first two folders that need to be copied across, and then further down the tree we have a couple of folders where there are files that need to be deleted. So in the traditional mode, which is delete and copy in one pass, what P5 does is it visits each folder in turn and either copies the files across or performs the deletions against the remote folder over here. So in this case there are some new files, so we would copy those new files across and they would show up over here. Again, in the next folder, as we work our way down, we copy those new files across. Now we come over here and we're going to delete some files and delete some files in these two folders. This can potentially lead to an issue where free space that you're expecting to obtain by these deletes is required for these new files up here to be copied across. And because you can't control the order in which the deletions and copying of files occurs, because it's just dependent on which folders we see first, you can end up with the destination disk becoming full. So the new deletion mode, first of all, traverses all the folders on the left hand side and performs the deletes, and then performs the copies afterwards of the new files. So now we will visit the deletion folders first and perform those deletes, and this is the first run of the two passes. So now we've freed space up by performing these two deletes, and then the next pass we'll copy the files across here and use the space that was potentially freed up by the deletes that happened first. The new two-pass deletion mode will take longer to run because it has to visit every folder first for the deletions and then for the copies. So there are two traversals of the file system instead of one with the traditional mechanism. The new Synchronize modes are accessed under the Synchronize module. Here's a sync plan I created earlier, and within my sync plan I'm going to look under Expert Settings, and you can see Deletion mode here, where the delete and copy in one pass, which was always the way that Archiware worked previously, is the default, and I can choose here to delete and then copy in two passes if I wish. The new throughput setting in the Synchronizer module allows better utilization of both disks and network performance. If you imagine that we have a couple of disks, one at the source and one at the destination end, each connected to a host running P5, and then the hosts are connected to a network. Initially, if we're talking about a LAN, then currently a single copy thread runs in the software between source and destination. Data goes through the LAN. This means that there's only a single thread reading the source storage and writing the destination storage at the other end. So the new option allows us to increase this up to 4 separate threads reading and writing between the two machines. In the case of a fast disk over here, this can result in higher performance overall copy performance because we're better able to utilize the speed of the disks that we're reading and writing. If we're writing across a WAN connection where there's likely to be much higher latency, then running multiple copy streams will reduce the effect, the overall effect that latency has on the copy speeds, and you're likely to be able to achieve higher throughput over the WAN link than you would by just running a single stream. Bear in mind though that this is an experimental feature. Let's have a look at how it's configured in the UI. So here we have a sync plan, and the tabbed interface across the top has an experimental section, experimental features. There's a description of what this means, and there's simply a drop down here which lets you increase between 1 and 4 separate parallel file transfers when this sync is running. The new restore from sync and manual sync options work as follows. So I'm in the Synchronize module here, and I'm just looking at 3 sync plans that I have configured. You'll notice each sync plan has its target folder listed here. So there are 3 folders where these sync plans are writing data to. So if I wanted to take something that had been written by one of these sync plans to these destinations and copy that file somewhere else, I can now do that via the Restore tab. So the Restore tab, when clicking on Synchronize on the left hand side, will show me my 3 sync plans and will allow me to browse those 3 destinations. So if I pick the middle one, I'm now browsing my mail server backup, and I can drill down, find something of interest in this sync destination like this log file, and then if I hit the sync to button at the bottom, I'm able to specify a destination that file will be copied to when I hit the select folder button. You can browse local folders and disks here, or by clicking on the clients button I can choose different machine, different client machine, and browse storage on that machine, and then I could choose a folder and restore the file back there. So that's the restore from Synchronize. The other option is under the Synchronize tab again, under manual sync, I can browse all of the file systems on all of my clients and make a manual selection, source and destination, and run an ad hoc sync plan. So if I pick this admin home folder here and go find something on the desktop, sample invoice.pdf, and clicking sync to brings up another file browser where I can choose a destination. In here I'm going to pick the local machine that I'm running, and I will put it in a folder users and shared. So we're going to select that source folder. If I just reveal that one in the Finder, click Start Sync, you'll see the job gets scheduled, and there the sample invoice file just popped up. So that's manual sync. So that covers everything that's new in version 5.6. Go download it today from p5.archiware.com.